In the last video, you saw how you can solve a system of equations by using substitution, and you basically just set two equations equal to each other. What we're going to be doing now is still called substitution, but it's going to look a little bit different. The concept is still the exact same, but it's maybe a little bit more difficult, but we've got plenty of examples in here to help you work through that. So let's get started on solving systems of equations by substitution once again. In the last assignment, we looked at equivalent forms of money, and we saw that $1 is the same as 2 quarters and 10 nickels. They're both still worth $1. One's just a little bit messier than the other one. Now suppose we have $13. We've got an Alexander Hamilton here. That's worth 10. And then we've got 3 $1 bills here. It makes $13. Well, you could, hypothetically, you could replace this dollar with a set of coins. You could replace the dollar with something that's a little bit messier, 2 quarters and 10 nickels. And then you could replace that other dollar that's behind it with another set of coins, and replace this dollar here with another set of coins. You would still have $13. We take the original 10 plus 3 messy sets of coins. You still have $13. We're going to take that same approach and that same logic to solving a system of equations. So let's go ahead and look at the first set of examples. I want you to pretend for a second that that Y is like your dollar bill. So pretend that this is like your dollar bill. And this X minus 6, that's like your stack of coins that you have. You can replace every dollar bill with that messy stack of coins. So do you see this dollar bill right here, this Y? We can replace that. We're going to substitute it with the messier version of it, the stack of coins. And let's see what that looks like. We have 3x plus 5, and now we're going to replace the Y, we're replacing that dollar bill with the messier version of it, that stack of coins. And we get equals 34. So all we did, just to summarize, we know that Y is equal to x minus 6, so wherever we see a Y, we substituted it with x minus 6. Now what we've done is we've turned it into one equation with one variable, and now we can just solve it like we did in quarter 1. So we're going to distribute the 5, and we get 3x plus 5x minus 30 equals 34. So we just took 5 and multiplied it to each thing in the parentheses. Now that we have variables on the same side, we can combine them together. So 3x plus 5x, they combine together to become 8x. And if we're trying to get x by itself, that minus 30, that's going to have to go. So we're going to add 30 to both sides. And we're left with 8x equals 64. To get rid of a multiply by 8, we just divide by 8. And we're left with 1x is equal to 8. And again, you might be proud of yourself. You just finished the problem and you want to move on. Remember, you can't do that. Remember, there's 2 variables that we have to solve for. We found x, we still have to find y. So now let's look at which one do you think would be easier to solve for y. Would you pick the top one or the bottom one? I think the top one looks way easier. So let's use the top one. We're going to have y equals x minus 6. I'll just rewrite it here. Y is equal to x minus 6. But now we know what x is equal to. We can replace x with 8. And if you subtract those, we get y equals 2. So we know that x is equal to 8, y is equal to 2. Make sure you write your answer as a coordinate, 8, 2. And that's the point where those 2 lines would intersect at 8, 2. Now, because we're going to be really good students, let's go ahead and double check our answer and just make sure that we got it correct. We know that it works for the top, but let's check the bottom one. Remember, x was 8 and y was equal to 2. If I replace x into here, 3 times 8 gives me 24. And if I replace a 2 in for the y, 5 times 2 gives me 10. And if I add 24 plus 10, it should equal 34. And it does. So we know we got the correct answer. If it doesn't work out, then you probably got the answer wrong. Go back and find your mistake. But it should work out for both the top equation and the bottom equation if you got it correct. Let's do one more example. We have x minus 3y equals 17 and y equals 2x plus 6. Now that dollar bill is on the bottom. So whichever variable is solved for you, you see y equals, that's what's going to be substituted in. So we know that y is equal to 2x plus 6. So wherever I see a y, I'm going to replace it with 2x plus 6. So I'm going to rewrite the top one. We have x minus 3, and then replace y with 2x plus 6 equals 17. So hopefully that makes sense. That y was kind of like your dollar bill, and this 2x plus 6 was like your big stack of coins, and we replaced this y with that stack of coins, 2x plus 6. Now it's just a matter of distributing and solving. So we're going to distribute the negative 3. So if we take negative 3 times a positive 2x, it becomes negative 6x. And if we take negative 3 times positive 6, that becomes negative 18. And we get equals 17. Once again, we have variables on the same side, so we are going to combine them. If you combine 1x with a minus 6x, it becomes minus 5x. Minus 18 equals 17, so we just combine the like terms. We still need to get rid of the minus 18, so let's go ahead and do that by adding 18. And we get negative 5x equals 35. Now x is being multiplied by a negative 5, so to cancel that out, we're dividing by negative 5. And we get x is equal to negative 7. And now we've solved for x. However, we still need to solve for y. So which one do you think would be easier to plug it into? The top one or the bottom one? I'd probably pick the bottom one. So y equals 2x plus 6. I'll use that one. So I'll rewrite that. Y equals 2x plus 6. And now we can just substitute the value that we just found. We can replace x with negative 7. So we do y equals 2 times negative 7 plus 6. If we take 2 times negative 7, that's going to be a negative 14. And if we add those together, we get y equals negative 8. So our x is negative 7, our y is negative 8, and our final answer would be written as a coordinate negative 7, negative 8. And there is your solution. So hopefully that makes sense. Go ahead and try the next one on your own and then see how you do. Remember, you can always double check your answer when you're done. So go ahead and pause the video. When you're done, come on back. All right, so I did the first step for you, just in case you got stuck on that one. You knew that y was equal to 6x minus 11, so you replace this y with 6x minus 11. From there, go ahead, distribute, combine like terms, and solve, and hopefully you do all right there. Let's go ahead and do a couple more examples just to make sure we understand what happens if they don't give you y, but they give you x. Well, the process is still the exact same. What this means is wherever you see an x, you can replace it. You can substitute it with 7y minus 4. So wherever I see an x, I'm substituting it with 7y minus 4. Well, I see an x right here, so I'm going to replace that x with 7y minus 4. And if I do that, it becomes 5 times 7y minus 4 minus 3y equals 12. So I took the x and I substituted it. That's why it's called substitution. Then we're going to distribute. the 5, and we're left with 35y. Subtract 20 minus 3y equals 12. We've got a couple like terms that we can combine. 35y, take away 3y. If you combine those, it becomes 32y. And if you want to get y by itself, that minus 20's got to go. So plus 20 to both sides. And we get 32y is equal to 32. So 32 times what number is 32? Well, it equals 1. And you can get that by dividing by 32 on both sides. And we get y is equal to 1. So we've solved for y, but we still need to find x. So let's decide which equation we want to use to do that. Top one or bottom one? You're right, I'd probably pick the top one. X equals 7y minus 4. So we get x equals 7y minus 4. And what we just solved was that y is equal to 1. So I can replace this y with a 1. So x equals 7 times 1 minus 4. And x equals 7 minus 4, which equals 3. So that's your x value. This is your y value. And you can write it as a coordinate. X is 3, y is 1, and there is your final solution. Let's go ahead and do one more. Again, we see that x is equal to 11 plus 2y. So what this means is wherever I see an x, I'm going to replace it with 11 plus 2y. So I see this x over here. I'm going to substitute it. So we have negative 7x, negative 7 times 11 plus 2y. The x got substituted. Then we have minus 2y equals negative 13. So we substituted the x. Now we're just going to distribute the negative 7. We get negative 77 minus 14y minus 2y equals negative 13. We can combine some like terms, so those y's are like terms, and that becomes negative 16y minus 77 equals negative 13. You might have written it the other way around, negative 77 minus 16y. It still equals the same thing. We can then get rid of the minus 77 by adding it to both sides. We get negative 16y equals a positive 64. And to get y by itself, we have to divide by the number that's in front of it, in this case, negative 16. And we get y equals a negative 4. So we've gone through and we've solved that y is equal to negative 4. Now let's go back and find the x. Which one would you rather use, the top or the bottom? I think the bottom one looks a lot easier. So x equals 11 plus 2y. And we now can replace, we found that y is equal to negative 4, so I'm going to replace this y with a negative 4. And if you do that, we get 11, a positive 2 times negative 4 is a negative 8. So 11 minus 8, which equals 3. So we found x is equal to 3. We knew that y was negative 4. Just write it as a coordinate, 3, negative 4. And there is your solution. Your password for this week is the word gumption. Gumption means like initiative. So you all have gumption because you are here watching this video and eager to learn it. So you have the initiative to go out and learn something. So that's called gumption. It kind of means the initiative to do something. So go ahead and try the last one on your own. When you're all done, submit your answers to Schoology so you can go get credit for this week's assignments. Thanks for joining, everyone, and we'll see you next time to solve with elimination.